Here's another one from Summary Review number 7. This is number 8, and the function over here is y equals x cubed plus 1 over x squared plus 2x, and we factor the bottom, can't factor the top. Well, actually it is the sum and difference of perfect cubes, but it's not going to make much difference. We'll have x plus 1 as a factor, and then the trinomial, so nothing's going to cancel, so we could leave it like that. Let's try to find some zeros here. That's always good. That kind of helped in the last one, saved us some asymptotic work there. So when x is 0, I have, well, I don't have anything because that's a vertical asymptote, so x can't be 0. So I don't have to worry about that. When x is 0, don't know what y is. And what's going to make y 0? Well, nothing's going to make y 0 because this is a, well, no, that's right, this could be -1. All right. And if I put a -1 in there, I'll have 1 minus 2, so I don't have 0 there, so -1. So why will it be 0 when x is -1? So I do have that point. -1, and I got to put it in here because I'm using this double scale, so that's the point 0, -1. I'm sorry, -1, 0. Okay, so we do have that point. Do we have any vertical asymptotes? Yeah, we sure do. Do we have any horizontal asymptotes? No, no horizontal asymptotes because the degree of the top is greater than the degree of the bottom, so no horizontal asymptotes. But we do have vertical asymptotes at x equals 0 and at x equals -2. So that's what's going to make the bottom 0. And notice that the degree of the top is 3 and the degree of the bottom is 2. So I have a slant asymptote, so I divide the bottom into the top. And I did that again over here, so save a little bit of time. This is number 8, so if I divide x squared plus 2x into x cubed plus 1, this is all the work, and you can see that we end up with x minus 2 plus this remainder. So we just look at the x minus 2, and there's your slant asymptote. So you can take a look at that, and if you don't have enough time, you can always just pause it. And that's your long division in order to find the slant asymptote. So I'll call the essay that's going to be x minus 2. So y equals x minus 2. So we could do that first, x minus 2. Again, the slope is up 1 over 1, and it's going to be starting at -2 to be the intercept. So that's what we've got, or up 2 over 2, the same difference, just going through -2. So there's our slant asymptote, our vertical asymptotes. We have a couple. Oh, man. Okay, x equals 0 and x equals -2. And x equals -2. Man. Okay, so my scale's kind of compressed. It's not going to really help me too much there. So I got this going through the center, so I pretty much got to check all the points around the asymptotes to see what's going on, because I could either go here or here. So I have to see, so we're going to have to use a small approach a lot. So, and it's definitely, it's not an odd function or an even function, because yeah, if I put a negative sign in here, it's going to really shift it all around. So there doesn't look to be any asymmetries anyway, so let's take a look at this. Man. Okay, so let's try as x approaches negative 2 from the left. So as x approaches negative 2 from the negative direction. So I can put this in, y equals, and I guess I could use this form here. And I could put negative 2 in here. That would just give me negative 8 plus 1. And I can put negative 2 in here. That's just negative 2. And then this is the part that I'm going to have some trouble with, so I have to write that out, x plus 2. Because if I put negative 2 in there, it gets 0. So this is going to be negative over negative is positive. This is going to be negative 7. So negative over negative is positive. So I'm going to have y equals 7 over 2. And then x plus 2. Now if I'm approaching negative 2 from the left, okay, then the number is going to be, I guess I have to do it over here. And the 7/2 is kind of just extra because we're going to get all the work over here as far as the infinity. So as I approach negative 2 from the left, it's going to be a little bit bigger, so it's going to be negative 2.0001. And then I'm going to add that to 2 plus 2. Hope you can see that. And this is going to be negative because the sign of the large is negative, so it's going to be negative 0.001 because negative 2.1 is to the right. I'm sorry, to the left of negative 2. Okay, so we're going to end up with 7 over 2 times, this is going to be negative 0.0001. So that means, so y will equal, and a negative, and then 1 over something very, very small, something very, very big like infinity, so I'm going to have negative infinity. So that means I'm going to be down over here. Okay. So we'll take this asymptote like this. Instead of going to positive infinity, since I'm going to negative infinity, then that tells me it's going to curve down around like this. Okay. Now how about as, now we've got this set up so we can use this over here. How about as x approaches negative 2 from the positive direction, I've got y equals 7 over 2, and this is the x plus 2, but that's going to be a little bigger, so that's going to be negative 1 point. It's going to be 99, pardon me. Negative 1.99999, which would be almost negative 2. And then I'm going to add 2. And that's going to give me 7 over 2 times, and this is going to be a positive, because positive 2, this is positive 2, if you can see that, positive 2. And then minus 1.999 will be positive 0.0001, we'll say. So that's a positive over a very, very small number would be positive infinity. So that's what I've got, positive infinity. Oops, you can see that over there. All right. So again, we're using a small approach. And I'm kind of cramped up in space here, so sorry about that. Okay, and we can see that we're going to go towards positive infinity because I've got negative 0.999 plus 2 will give me a positive, and everything else was positive. So it looks like, and I have this point here, but I've got these two asymptotes. I've got to work along these, so I'm going like this. Okay, now is this going to go back up or is it going to squiggle down like this? I'm not too sure. So I'll have to check and see what's happening as I approach 0. And I'll do that over here. Now, if we go back to our function, then this won't be a problem. This is where the problem will be. So I could say y equals, and I could put 0 in the top. So I've got 0 for x cubed plus 1 all over, and then I have to leave the x there, and then I've got 0 plus 2 is just 2, or 2x. So I just end up with 1/2, or 1 over 2x. So as I approach x from the right, it's not going to be too bad, because as x approaches 0 from the negative direction, I should say from the left, that's just going to be 1 over 2 times, and it's going to be very, very small, so it's just going to be negative. Okay, just barely away from 0, so that's just going to be, looks like negative infinity. 1/2, and this is going to be so small. Something over a very small number would be negative. So it looks like I got negative infinity. So it looks like it is going down like this. So it's kind of squiggling down like that. Okay, hope you can kind of see that. Rather than going back up, it's going down. So there's my function. And then the last thing, what's going to happen over here? Am I going to be over here or over here? So let's see what happens as as x approaches 0 from the positive direction. So that's again going to be 1 over 2x. And y will be, sorry about that, y will be 1 over 2, so this is going to be a positive, so it would be 0.00, positive 0.1, and that's again just going to be positive infinity. That looks like that's no problem. Very small number, it's going to be positive because I'm approaching 0 from the positive direction, so real close to the positive direction, so that would be just positive infinity. So it looks like we're okay. So it looks like we're going to come down like this from positive infinity and curve around here somewhere like this and head towards that asymptote. So this is looks like what we've got. Okay.